This video is over lesson 34, decimal numbers on the number line, and it is for my 7th grade math class. So sorry, I've got terrible lighting, but if we take a look here at a number line, we've done number lines before. This number line I've chosen to put 0 here on the left, 1 in the middle, and 2 way over here on the end. Now, just because of how the computer worked, this is not ideally how you would actually put your tick marks in. Typically, we don't put a tick mark in where the arrow is. Usually the line and the arrow go beyond the tick marks. But this is the best that I could do with the computer. But anyways, so I've got 0, 1, and 2 here on my number line. And as the title suggests, we want to take a look at the decimal number line. So the decimal numbers on the number line. Well, in a previous lesson, we had learned that decimals are really what are called decimal fractions. Now, we don't call them that very often. In fact, most of you probably never heard that term before we did that in a previous lesson. But you can think of them as a special kind of fraction. And so they're going to break the whole numbers up into a certain number of pieces. Now, what's special about them is they specifically break things up into tens. So since they're part of our place values are based on 10. So if we count the number of spaces from 0 to 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. Okay, so this has been broken up into decimals. Now, in order to help us with this, if we've broken this up into 10 spaces, then we're going to have one more decimal place. Well, whole numbers don't have a decimal place at all, so we want to kind of reimagine each of these whole numbers with a single decimal place. So 0 becomes 0.0, 1 becomes 1.0, and 2 becomes 2.0. Now from here, this can be very helpful because if we ignore the decimal, it looks like 0, 10, and 20, and that will actually help us to figure out what our decimals will be. So if we think about this as going from 0 to 10, then the first tick mark here should be 1, but it's not really 1, it's really 0.1. The next tick mark should be 2, but it's not really 2, it's 0.2. And I hope by now we're kind of catching on. So the next one should be 0.3, it looks like a 3. Then 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then 1, which is really 1.0, looks like our 10 if we include that first decimal place. And so there's our decimal places in between 0 and 1. Now if we continue on from 1 to 2, this looks like we're going from 10 to 20. So this should look like 11, but it's not really 11, it's 1.1. This should look like 12, but it's really 1.2. This should look like 13, but it's really 1.3. 14, but it's really 1.4. 15, but it's really 1.5. 1.6, 1.7, 1.8, and 1.9. And so hopefully you found that fairly easy as long as we were thinking about our whole numbers with that extra decimal place. Okay. So we're going to go deeper into this now, and we're going to try to create a little bit of a zooming out or a zooming in effect if we can. And so we'll see how well we can do this. And what I'd like to do is I'd like to zoom in between 1.4 and 1.5. So highlight those separately for me with your yellow. And so what we're going to do is we're going to bring this down here, and this is going to be my 1.4, and this is going to be my 1.5. And then I'm going to highlight those as well, and then using the tip of my marker, and I'm going to draw lines between those. So if you can imagine this on your phone, it's like you've taken these two numbers here on the number line, like we put our fingers on here and we've pushed them apart so we can zoom in on the in-between space between them. So you can kind of think of it like that, like something you might do on your tablet or on your phone. So we've just zoomed in now to see what's in between 1.4 and 1.5. Now, if we're going to go to another decimal place, then it will be helpful to rethink of these numbers as having one more decimal place. So 1.4 is really 1.40. We just got to put in that hidden 0 after the 4. And so 1.5 would be 1.50. So if we ignore the decimal here, this is going to look like we're counting from 140 up to 150. So that means my first tick mark then must look like 141. Now it's not 141, it's actually 1.41. It just looks like 141. So the next one's going to look like 142, but it's not actually 142, it's 1.42. And so the next one will look like 143, but it's really 1.43. The next one will be 1.44. It looks like 144. Then we have 1.45. And I kind of messed that up again. I almost put a 5 first. There we go. So next after that would look like 146, but it's really 1.46. Then we have 1.47. That looks like 147. 1.48. That looks like 148. And then finally, my last tick mark there is 1.49, because after what looks like 149 should come 150, which was my 1.5, or my 1.50. So again, by reimagining these two numbers with an extra decimal place, hopefully helps you just count up. Well, we're going to dive deeper yet. So grab let's grab your green next. And we're going to zoom in this time in between the 1.4 and the 1.41. 1.4 and 1.41. And so I'm going to put my 1.4 here. I'm going to put my 1.41 there. And so I'm going to then draw and highlight these as well. Now, first of all, so it was 1.4 that comes down here, but this is 1.41. So we do want to imagine these having the same number of decimal places. So I'll put a little red 0 there. And so now when I add on an extra decimal place, this becomes 1.400. And this becomes 1.410. So it is important in order for this to work that we have the same number of decimal places. So 3 decimal places, 3 decimal places. Now it looks like we're counting up from 1,400 to 1,410. So for this one, my decimals are becoming long enough that I'm going to turn my paper sideways. So after what looks like 1,400 would come what looks like 1,401. But it's really 1.401. Then 1,402, but it's really 1.402. 1,403, but it really is 1.403. So next will be 1.404, 1.405, 1.406, 1.407, 1.408, 1.409, and so next should come 1.410, although we don't say 10, 1.410, and there it is. All right, and we're going to go one step further. Let's just keep diving deeper and deeper. We can, as long as we got the hang of this, we can go as deep as we need to or as we want to. So this time, we're going to zoom in between these two numbers here. So 1.407 and 1.408. So imagine you're taking your phone and splitting those apart. So over here, I've got my 1.407. Over here, 1.408. And I'm going to complete my highlighting now. We're zooming in there. And so what would we find between these two numbers? Well, we're going one more decimal place down. So first things first, reimagine these with an extra decimal place. So 1.4070, and over here 1.4080. And so you can see very quickly each time we add it on the decimal place, it makes the number that this looks like look even bigger and bigger and bigger. So now we're up to a number that without the decimal, this looks like 14,070. This looks like 14,080. Well, really, guys, that's really just 14,000 everywhere, but then we're just counting up from 70 to 80, really. Okay, so the 14,000, but then we're counting up from 70 to 80. So if I turn my paper sideways, I've got my 14,000, but then 71. Put your decimal in. 14,000, but then 72. Put your decimal in. 14,073. Put your decimal in. So we really have 1.4071, 1.4072, 1.4703. So next is 1.4074, then 1.4075, 1.4076, looks like the 76, 1.4077, which is really 77, 1.4078, looks like 78, and 1.4079. And after the thing that looks like 79 should come the thing that looks like 80. And there we are. Now, on the homework, you're not typically going to have to dive this deep. Usually, on the homework, you're just going to have to either go from whole numbers to tenths, or you'll have to go from tenths to hundredths. I'd be surprised if there was anywhere in the homework where we had to dive as deep as we went here, but I want you to understand the structure of this. I want you to understand that you can continue to go down and down and down and down, further and further and further. So, next up, we're going to talk about the centimeter ruler. So remember, we learned about the metric system in a previous lesson. The metric system is all based on 10. It lends itself to a decimal system. So the margin of error on a ruler is usually about half the distance between two tick marks. So margin of error is half the distance between two tick marks. Okay. So if we're looking at it and we can't tell, we're looking at it, it's like, it looks close to this. If it's less than halfway to another number, we can be pretty confident that we've got the correct number. If you're more than half away from half a mark off from your answer, you should have measured it better. So margin of error, we say, is about half the distance between two tick marks. So the tick mark halfway between two whole numbers is usually larger than the other tick marks between the whole numbers. So talking about the centimeter ruler. So the 0.5 is usually going to be a lot bigger than the other tick marks along the way. So with that being said, I'd like you to please grab your math books. Go ahead and pause the video until you're all set, but you're going to open up to page 243, and we're going to do some practice problems. So pause the video, 243. All right, hopefully you got your book open there then. And we're going to take a look at practice problem A, and unfortunately I don't have a physical book with me here right now, so we're going to have to just kind of discuss what we see, but hopefully you're looking at your book and you can see it there, and I've got my book on my screen here. So on problem A, we're given this mark next to a centimeter, what looks like a centimeter ruler, and we're asked to find the length in centimeters. So you see the 1, you see the 2, you see the 3, and then the ruler breaks after the 3. And then we see all the little tick marks in between the whole numbers. And so as we look at all the little marks between the whole numbers, if I come down here on my dry erase board, so if I've got my whole numbers, let's say, so let's say this is 1 and this is 2, okay? Halfway in between them, you've got a larger tick mark, and you've got 4 smaller tick marks in between each of those. Okay, this is your decimal number line. It's just they've given you the 0.5 right here. Now in between 1 and 2 though, this would be 1.5. Oops, sorry, I have a glare spot. So there we go. So 1.5, because between the 1 and the 2, so it gives you the 0.5. So it means every other tick mark is just another tenth beyond that. So if we think about this, 1 is really 1.0, 2 is really 2.0. So this is like counting up from 10 to 20. So that means that this tick mark here really is 1.1. This is 1.2, 1.3, 1.4. The big guy's 1.5. So that means that if you want to find this guy right here, well, you already know that this is 1.5, so that must be 1.6. And then we got 1.7, 1.8, and 1.9, and we finish off with 2, the whole number 2. So if you look at your book, you'll see that the line that's drawn above the ruler comes to about right there. And so if we look down at the ruler, it seems to be one tiny tick mark beyond that 0.5, which means that that segment, according to that ruler, must be 1.6 centimeters long. Now B, this is where we're going to use some previous knowledge. So we learned in the previous lesson about the metric system that 1 centimeter is 10 millimeters. That means that on a centimeter ruler, every tiny tick mark is actually a single millimeter. So if we have 1.6 centimeters, that's, well, scoot that decimal over once, that's 16 little tick marks. So therefore, it must be 16 millimeters long. So if you just count the little tick marks as whole numbers, each whole number then would be 10 little tick marks. You've got 16 millimeters. Moving on to letter C. Letter C, what is the greatest possible error of the measurement in problem B? Express your answer as a fraction of a millimeter. So remember what we talked about up here, that margin of error equals half the distance between two tick marks. So the margin of error is going to equal half of is times the distance between two tick marks. So since letter B was asking about millimeters, what's the distance between two tick marks then? Well, it's a single millimeter. So this is half times 1 millimeter. Well, a half times 1 is just 1/2. So this is half of a millimeter. And so all that's telling us then is you're not likely to ever be more than half a millimeter wrong as long as you're measuring correctly. So you could be a quarter of a millimeter off, just because it might maybe just a little bit longer than you guessed, or it's a little shorter. You could be up to that, but you're not likely to be beyond half a millimeter wrong, because if it's more than halfway to the next guy, then you're going to call it the next guy. Okay, so if your line here were to go, more than halfway, it's going to look more like the 1.7 than the 1.6. Okay, if it goes a little beyond the 1.6, it's not halfway. We're likely to call it the 1.6, and so that's where that 1/2 comes from. Okay. All right, I'm out of space. I'm going to the back here, but we're going to continue with the practice problems. So next up is D. D says 75 centimeters is how many millimeters? So this is basically asking 75 centimeters is how many meters? And as we've learned to do these before, we make ourselves a little chart. And so I'm going to take the amount that I'm trying to change, 75 centimeters, and I'm going to put it there in the top left. Now, essentially what we're creating is a bunch of fractions here. So I want to turn this into a fraction. I'm just going to put a 1 in the bottom, and there we go, we got our fraction. Now, next, in this section, we put our conversions. So if we have centimeters and we want meters, we learned in that previous lesson that 1 meter, well, centa means 100, so 1 meter is 100 centimeters. And so now we got to decide where to put these two amounts. So 1 meter is either going in the top or the bottom. 100 centimeters will go in the other spot. Now my goal here is I want the centimeters to go away and I want meters to be left over. So centimeters will cancel with centimeters as long as one's on top and one's on bottom. So I want to put the 100 centimeters down here so that centimeters and centimeters will cancel, which means that my 1 meter has to go on top. So again, just to notice what's going on here, 1 meter equals 100 centimeters. And so notice I've got 1 meter, I've got 100 centimeters, just like it said here. But then we have centimeters on top and centimeters on bottom, so that they'll cancel. Now if we go ahead and do our math, we're basically going to treat this like two fractions being multiplied. And so 75 times 1 is 75, but the meters will tag along. 1 times 100 is 100, but these are canceled, so they're not going to tag along. And then to finish it off, 75 divided by 100 is actually real easy because when we divide by 100, we're just going to move the decimal 2 times to make it smaller. So scoot that decimal over, boom, boom, 2 times, 0.75 meters. Now you may have asked yourself, but Mr. Burford, couldn't I have just reduced before multiplying? And the answer here is yes, but when you're working with the metric system, I would say don't do it. Don't do it because it's actually going to be much easier if you leave that 100 or that 10 or that 1,000, whatever it ends up happening to be. If you just leave that there, because then all you got to do is move the decimal to find your answer, which is going to be much easier than trying to reduce fractions. So 0.75 meters is my answer there. Now, with that being said, I do want to show you how to do this one other time. So instead of making a chart, the alternative option is that we literally make fractions. But the two fractions that we make come straight from the chart that we just made. So 75 centimeters becomes 75 centimeters over 1. And then these two conversions that we put in the chart just become their own fraction. And so from there, centimeters and centimeters will still cancel. Up top we'll still get 75 meters. On bottom we'll still get 100, which means the answer is still 0.75 meters. So when it comes to the homework, I don't really care which one of these two methods that you use as long as you use one of them. Excuse me. So you can use the top method, the chart. You can use the bottom method with the fractions. I don't really care. They both work. They're both going to get you the right answer. They're both very similar too. All right, moving on to E. So letter E. Carmen's wardrobe closet is 1.57 meters tall. How many centimeters tall is it? So again, we've got 1.57 meter tall closet, wardrobe closet, and we want to know how many centimeters is that. So that's the problem being asked. So I'm just going to go with the chart. Keep things simple. So 1.57 meters is the number that we're trying to change. We're going to fill in this spot with a 1. And then we got to think, okay, well, what do we know? Okay, I got meters, I want centimeters. Well, it's the same thing we knew before. 1 meter equals 100 centimeters. But this time, because I have meters on top, in order to cancel those, I need to have meters on bottom. So my 1 meter is going to have to go on bottom, which means my 100 centimeters is going to have to go on top. Now meters and meters will cancel. And so if we multiply this together, up top 1.57 times 100, So times 100 will make that decimal move 2 times, but make it bigger. So 1 2 times will make that 157 centimeters. Excuse me. And then on bottom, 1 times 1 is 1. Now divide by 1. That's simple. 157 divided by 1 is 157. And don't forget your centimeters. Moving on to F. What point on a number line is halfway between 2.6 and 2.7? So for this one, what I'd like you to do is I'd like you to write 2.6. I'd like you to leave some space, write 2.7. So if I want to know what's halfway in between these two, let's do what we did on the front. So when we wanted to know what was in between 1.4 and 1.5, we added in an extra decimal place. So let's add in our extra decimal place. So 2.6 is really 2.60. 2.7 is really 2.70. Now just look at those two numbers. If we took the decimal out, this looks like 260 and 270. So what's halfway between 260 and 270? Isn't it 265? And then put your decimal in, and you got your answer. And there it is. So G gives us a number line. It says, what decimal number names the point marked A on this number line? So when it comes to a number line, you've got it already written there. I'm not going to make you write this one out as much, but you know, we've got 10.0 compared to 10.1, and since we do have the number line to look at, this one you can do just a little bit more thinking on. So we still want to think about adding in that extra decimal place. And so now it looks like we're counting from 1,000 to 1,010. So A, being on just the first tick mark after this, is going to look like 1,001. But of course it's not actually 1,001. We got to put our decimal in. It's actually 10.01. So as long as you just add in that extra decimal place, or imagine adding in that extra decimal place, it's just a matter of counting. So it's one more. All right, H. For letter H, we're asked to estimate the length of this segment in centimeters, and then we're going to use a ruler to actually measure its length. So what I'd like you to do here is I'd like you to write estimate, or estimate, and then a colon, and then actual, and a colon. And then what I would like you to do now is, once I've given you all the instructions, pause the video, and then you're going to do what I'm telling you to do. Okay, so just get all the instructions first. So first thing you're going to do here is you're going to make an estimate. How many centimeters do you think this is? Do you think it's 154? By the way, it's not 154. Do you think it's 1? It's not 1. But how many centimeters do you think this is? Okay. And then once you've got your estimate written on the paper, you're going to go grab a ruler and you're going to actually measure this to find out how many centimeters long it is. And then once everybody's settled, we can go ahead and you can hit play again, and we'll see how you did. So go ahead and pause now. All right, let's see how you did. So for an estimate, if you'd had an estimate around 4 centimeters or 5 centimeters, or even 6 centimeters, I would have said that that would have been okay. Those all would have been okay estimates. So don't feel like you've got to write all those down, but as long as yours is one of those are all pretty reasonable estimates there. And so then when you actually measured it, you should have found out that it is actually 5 centimeters long. All right, which brings us now to the letter I. So letter I, we're going to compare 4.6 to 4.4. 4, 5. And so as we've learned in a previous lesson, there's a couple different ways that we can compare these. So one way that we can compare these is by adding in an extra 0 here so that they have the same number of decimal places. And now that they have the same number of decimal places, ignore the decimal. What does this look like? Well, this looks like 460. This looks like 445. So which is bigger? Well, 60 is bigger than 45. So if that's bigger, then it's also bigger there. So that's one way to compare these. Another way to compare them would be to take a look at their place values. So if I start with the ones place, they both have 4s, so that's a tie. Move on to the next place, the tenths. This has a 6, but this has a 4. Well, which is bigger? 6. So a couple different ways to do that one. Which brings us to our last practice problem, J. And so J is asking us to compare 2.5 centimeters to 25 millimeters. And now this one's easy enough that you may already know the answer, but I do want the full work here because I want us to practice what to do so that way when harder problems come along, we know what to do. So when we have something like this, it's a good idea to convert them both into the same units. So I'm going to come over here to the side, and I'm going to take that 2.5 centimeters and make my chart, and let's convert those into millimeters. And so we already know that 1 centimeter is 10 millimeters. So in order to cancel out the centimeters, centimeters has to be on top and on bottom. So that'll be my 1 centimeter is on bottom, my 10 millimeters are on top. So centimeters cancel with centimeters. And so then my answer here is going to be 2.5 times 10, so that's going to move the decimal once, make that 25 millimeters over 1. Now I don't really need a final answer here, so yeah, I know it's 25 millimeters. I'm not going to bother write it there. I'm going to take this though, and 2.5 centimeters we just found out was 25 millimeters. So I'm going to replace that there. We're comparing that to 25 millimeters. So how does 25 millimeters compare to 25 millimeters? Well, they're equal, of course, which means that these are equal as well. And so that's what I'd like to see on a problem like this. And that is the end of our lesson.